Yo, what's up YouTube? Kiwi the Cat here with a new video, and today we're talking about how to solve quadratic equations. Whether you're taking the SAT or any math course, you have to know how to do this like the back of your hand. When solving quadratics, we're looking for when the graph crosses the x-axis, and the main ways to do that are graphically and algebraically. Today we're looking at the two main ways to algebraically solve these equations. Either 1, we can use the quadratic formula, or 2, we can factor our equation and solve for x. If you want to see how to solve these equations graphically, a video should pop up in the top right of your screen right about now, and it explains it thoroughly. Also, I will link it in the description below. Okay, let's get right into the first method. Okay, so the first method is the quadratic formula. The quadratic formula is literally just a formula that you can use to find all zeros for a quadratic equation. I recommend that you guys memorize this formula for the SAT or for any algebra-based course. Now there's a few things you have to know before you use the quadratic formula. You can only use this formula when a quadratic is in standard form, aka when it's in ax squared plus bx plus c form. The reason it has to be in standard form is because a, b, and c, as you can see in the equation, all have to come from the quadratic in standard form. Another thing you should know is that you can use the quadratic formula for any quadratic equation. It's just that you're going to have to go ahead and transfer that quadratic equation back to standard form before you use it. Overall, you can use this method to go ahead and solve any type of quadratic equation you see on a test or in class. Okay, let's practice using the quadratic formula. For these three equations, I want you guys to use the quadratic formula to find all real zeros. Feel free to pause, get your answers, and resume when you have them. Okay, first question. So we know the formula for the quadratic formula. That's negative b plus or minus the square root of b squared minus 4ac all over 2a. So here we know 1 is a, 5 is b, and 6 is c. And we know this is in standard form, so we can just go straight into the equation. This gives us negative 5 plus or minus the square root of 5 squared minus 4 times 1 times 6 all over 2 times 1. This gives us negative 5 plus or minus 5 squared is 25 minus 4 times 1 is 4 and 4 times 6 is 24 all over 2. Moving this up here. Now we have negative 5 plus or minus the square root. 25 minus 24 is 1 all over 2. Now we have negative 5 plus or minus the square root of 1 is 1 over 2. Now once we get to this step, we have two types of equations. We have negative 5 plus 1 over 2 and negative 5 minus 1 over 2. That's what this plus or minus means. So doing that, we have negative 5 plus 1 over 2, and we have negative 5 minus 1 over 2. Doing this side first, we get negative 4 over 2. This gives us negative 2 as one of our zeros. And doing this right side one, we have negative 6 over 2. This gives us negative 3 as one of our zeros. So our two zeros are negative 2 and negative 3. Checking our answer, we got it correct. Okay, next question. You see this is in standard form, so we can just go ahead and go straight to the formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. 2 is a, 7 is b, 3 is c. Here we have negative 7 plus or minus the square root of 7 squared minus 4 times 2 times 3 all over 2 times 2. This leaves us with negative 7 plus or minus the square root. 7 squared is 49 minus 2 times 3 is 6. 6 times 4 is 24. And 2 times 2 is 4. Moving this up here, we have -7 plus or minus the square root. 49 minus 24 is 25 all over 4. -7 plus or minus the square root of 25 is 5 all over 4. Just like the last problem, we have to split this up. So we'll have -7 plus 5 over 4 and -7 minus 5 over 4 is one of our zeros. -7 plus 5 is -2. That's -2 over 4. That's equal to -1/2 as one of our zeros. -7 minus 5 is -12 over 4, which leaves us with -3 as another one of our zeros. So -1/2 and -3 are our two zeros. Checking our answer, we got that right as well. Okay, last one. This is also in standard form, so we can just go straight to the quadratic formula. -b plus or minus the square root of b squared minus 4ac all over 2a. This gives us -12 plus or minus the square root of 12 squared minus 4 times 1 times 32 all over 2 times 1. This gives us -12 plus or minus 12 squared is 144 minus 4 times 1 is 4 times 32 is 128 all over 2. Moving this up, -12 plus or minus 144 minus 128 is 16 all over 2. -12 plus or minus the square root of 16 is 4 all over 2. Here we have to split. We have -12 plus 4 over 2 and -12 minus 4 over 2. -12 plus 4 is -8. It leaves us -8 over 2. This gives us -4. -12 minus 4 is -16 over 2. This gives us -8. For our two zeros are -4 and -8. Checking our answer, we got it right. Okay, let's look at the other method for finding quadratic solutions. That is the factor. So there's three main steps that we use to factor any type of quadratic equation. The first is to find and factor out any of the GCFs. The second, when we're talking about a, we're talking about a in standard form. If it's greater than 1, we have to use machine. If not, we use the distributive way. These two methods are just ways of factoring that we're going to cover in a few seconds. And our third step, sometimes you may find that factoring just doesn't work, or sometimes you may find that we just have no solutions. In either case, we have to use the quadratic formula, which we just went over. Okay, let's look at the distributive way to factor. So this factoring method is most used, especially on the SAT. The first step to doing the distributive way is to take our C value and find all the factors for C. When we use the distributive way, just know that we have to be in standard form. Our second step is to find a pair of factors that add up to our B value but multiply to C. This may seem complicated, but it gets very easy very quickly, and you'll see how easy it is when we do our practice problems. Once we find these factors that add to B but multiply to C, we take those pairs and add x in front. Then we set each pair equal to 0 and solve for x. Okay, let's practice using the distributive method. For these three equations, I want you guys to use the distributive method to go ahead and solve. Feel free to pause, and when you're done, resume. Okay, first question. So we know the first step is to make sure everything's in standard form. This is in standard form, so we're all good to go. The next step is to look for all our factors of C. So C in this case is 25. So we know that 25 has a couple of factors. We have 1 and 25, and we have 5 and 5. Now we need to go ahead and test one of these pairs. One of these have to add to 10 and multiply to 25. All these multiply to 25, so we just need a pair of these to add to 10. 1 and 25 add to 26, so that won't work. 5 and 5 add up to 10, so this does work. Here's a good pair. Next, we add x in front. So we had x in front of one pair, x plus 5. X in front of another pair, x plus 5. Lastly, we set each one of these pairs equal to 0. X plus 5 equal to 0. And x plus 5 again equal to 0. And now we solve for x. Because these are the same equation, we know we're going to get the same answer twice. So I'm only going to do it once. X plus 5, we subtract 5 on both sides, and we get x is equal to negative 5. So we know we have one solution at x is equal to negative 5. More than likely, since we only have one solution, the vertex is on the x-axis in this graph. Checking our answer. Yep, we got x plus 5, x plus 5. Okay, next question. Here, we see it's in standard form, so we're all good to go. Taking our factors of our c value, c in this case is 15. Factors of 15, we have 1 and 15. And we have 3 and 5. We need two factors that add up to b. 1 and 15 add up to 16, that's not 8. 3 and 5 add up to b, because that is 8. Now we add x in front of each one of these pairs. So we have x plus 3, x plus 5. Now that our equation's factored, we can go ahead and solve for x by setting each one of these equations equal to 0. X plus 3 equal to 0. X plus 5 equal to 0. We have x is equal to negative 3. And x is equal to negative 5. Checking our answer. We got that correct as well. Okay, lastly, you see again that it's in standard form, so we're all good to go. We need to find factors of c, which in this case is 12. 12 has multiple factors. We have 1 and 12, 2 and 6, 3 and 4, and that's it. We need one of these pairs to go ahead and add up to 7, because 7 is our b value. 1 and 12 add up to 13, that's not 7. 2 and 6 add up to 8, that's not 7. 3 and 4 does add up to 7, so we can use this pair. Next, we add x to in front of each one, x plus 3, x plus 4. Now that our equation is factored, we can set each one of these pairs equal to 0 and solve for x. Here we get x is equal to negative 3 and x is equal to negative 4. Checking our answer. We got that right as well. Okay, our next method for factoring is machine. Now there's two things we have to know before using machine. Number 1, our equation has to be in standard form. And number 2, a has to be greater than 1. So the first step is to find factors of c and a and list them out. Our second step is to try each pair of factors of a with c until we get one. When cross multiplied, gets added to b. Lastly, we take pairs horizontally, set equal to 0, and solve for x. This method does require more steps, so be sure to watch these example problems in the next few seconds to make sure you go ahead and get it down. Okay, let's practice using the machine. For these three equations, I want you guys to go ahead and at least try to go ahead and factor using machine. Feel free to pause, and when you're done, resume. So as we see, we're in standard form, so we're good to go. First, we're going to find factors of a and factors of c. So here for a, I see we have factor of 1 and 8, and 2 and 4. For c, we have negative 1 and 3, and we have 3, negative 1. For these a values, we have to make sure to put an x on each one to make sure we get an x squared. So we're going to put 1x, 8x, 2x, and 4x. Now we have to cross multiply one of these pairs with one of these pairs, and hopefully when cross multiplied and added together, they get b. I'm going to try 2x, 4x, negative 1, and 3 first. Cross multiplying 2x to 3x, we get 6x. 4x to negative 1, we get negative 4x. Adding these together, we get 2x. This is equal to b, so no, this is our correct pair. Now make sure we take these pairs horizontally. So we get 2x and -1, and we get 4x and 3 as our two pairs. So we have 2x and -1, and 4x and 3. These are now our two equations in factored form. We could go ahead and solve this for 0 if we want our x-intercepts. Checking our answer. We got it right. Next question. 3x squared plus 7x plus 2. This is in standard form, so we can go straight into machine. First thing we want to do is find factors of 3 and 2 because that's our A and our C. 3 only has two factors, 1 and 3. 2 only has one factor, 1 and 2. Cross multiplying, we have 3 and 1. Now we make sure to add x for both our A values. Make sure it adds up or multiplies up to x squared. Cross multiplying, we have 3x. And then x times 2 is 2x. This gives us 5x, so we know that's not our pair. I'm going to go ahead and swap these around to get a new pair. Let's do 3x and x instead, and 1 and 2 again. 3x times 2 is 6x. X times 1 is x. 6x plus x is equal to 7x. This is equal to b, so we know we have our pair. Now we take these two values across, and we have 3x plus 1 and x plus 2. This is our equation in factored form. Checking our answer. We got that right as well. Okay, last problem. This is in standard form, so we can go straight into machine. We're going to list out our factors of A and C. 5 has factors of 1 and 5. 6 has factors of 2, 3, 6, 1. Let's try 2 and 3 first. Make sure we add x to both our A values. 5x and 2, that's 10x. X and 3 is 3x. 10x plus 3x is equal to 13x, which is equal to b. So we know we have our right pair. Taking this across. Here we have x plus 2. And here we have 5x plus 3. This is our quadratic in factored form. Checking our answer. We got it right. Okay, now let's look at factoring not in ax squared plus bx plus c form, or standard form. Now there are going to be some times where you're going to be asked to factor an equation and it's either not in this form or it's very close to it. I'll put 4 steps to go ahead and solve any equation, including equations not in ax squared plus bx plus c form. The first thing we want to go ahead and try and do is either use the distributive property or FOIL to expand back into base form. Our second step is decide if value of a can be factored down to 1. Our third step is use the distributive way or machine to go ahead and factor. And our last step is to set equal to 0 and solve for x. Okay, let's practice factoring not in standard form. I want you guys to go ahead and factor these 4 equations. Feel free to pause and resume when you have your answers. Okay, first we have 100x squared plus 1000x. As you can see, we have no c value, so we can't use the normal distributive way. However, we do see a GCF. Both of these numbers have a common factor of 100x, so I'm going to go ahead and take out this GCF. Now dividing 100x squared by 100x leaves us with x, and dividing 1000x by 100x leaves us with 10. Now we can set each one of these values equal to 0. 100x equal to 0 will give us x equals 0, but x plus 10 equal to 0. We subtract 10 on both sides, thus x equals -10. So this would be our factored form. This would be our x-intercept or our solution. Checking our answer, and we got it right. Okay, next question. So while this isn't in standard form, we do know that this is in solution form, or this is already in factored form. Because of this, we don't even have to factor, so it would just be the same answer. Here, we have an equation in vertex form. The first thing I want to go ahead and do is try to FOIL. So I'm going to go ahead and factor x plus 2 and FOIL it out. To FOIL, I take this first term and multiply it by each one of these terms, and I take my second term and multiply by each one of these terms and add them all together. So x times x is x squared. X times 2 is 2x. 2 times x is 2x. 2 times 2 is 4. Adding like terms, we have x squared plus 4x plus 4 minus 1. Subtracting our constants, we have x squared plus 4x plus 3. Now that we're in standard form, we can use the distributive way. In doing so, we look for factors of 3. We have 1 and 3. Luckily for us, this adds up to b, because 1 plus 3 is 4, which is equal to b. So this is going to be our two terms. So we're going to add x to both, x plus 1, x plus 3. And this is our factored out expression from vertex form. Checking our answer, and we got it right. Last question. This seems to also be in vertex form, so I'm going to go ahead and try to FOIL it out. So we have 3 x plus 2 times x plus 2. Remember to FOIL, we multiply each term by each other. So x times x is x squared. X times 2 is 2x. 2 times x is 2x. And 2 times 2 is 4. This leaves us with x squared plus 4x plus 4. Now we can use the distributive method. Listing our factors of c, we have 1 and 4, and 2 and 2. I know 2 and 2 adds up to 4, and 1 and 4 adds to 5, so I'm going to use 2 and 2 because that equals b. Adding x to each one of these pairs, we have x plus 2 and x plus 2. This is our vertex form in factored form. Checking our answer, and we got it right. Okay, lastly, I got some tips and tricks for you guys. So if you're ever factoring and you see any equation in the form x squared minus y squared, an example could be x squared minus 4. This is called the difference of two squares, because if you take the square root of 4 and it's square root of x, you'll get a whole number. Every equation where we have the difference of two squares can be factored down to x plus y and x minus y. This eliminates the need of factoring using distributive or machine. This is very common on the SAT, and they love to put this on there. The next tip is if you're very confused, try to graph on an xy plane by picking random x's to plug into your equation and getting out corresponding y's. Then see where the graph crosses the x-axis, and those are your zeros. So if you ever get an equation where it's either just too complicated or you're factoring and it's not working, try picking out some x's, plugging it in for y, draw a little graph, and see where it crosses the x-axis. My last tip is use the quadratic formula if you're having any trouble. Let's say you have a really complicated equation and you're trying using the machine and machine just isn't working. You can always use the quadratic formula to go ahead and solve it out. Okay guys, that's the end of the video. If this helps you solve quadratic equations, make sure to leave a like. Also, make sure to check out all my other videos on factoring, equations, etc. See you guys.